Okay, welcome to part two. So this is where I'm going to start with range. I will definitely talk about range and interquartile range, and then most likely start part three with standard deviation. Okay, so I would definitely suggest at this point, if you haven't already gotten a pen, pencil, paper, and some stuff to write with, now is the time to go ahead and do that. I actually have something set up on my laptop and on my computer where I can write, I can actually write directly onto the screen. So you're going to see me do some of the calculations as I am working through things. You'll get to see me do some of that. So one thing I'm going to say though is just bear with me. It's new technology. So sometimes it may go to another slide when I'm actually trying to write something. Just bear with me. I'll get it back to the right slide. And I'm not going to say that the handwriting will be the prettiest, but you'll at least get to see me do calculations, and you'll get to see me as I work through things and my suggestions for how you do things. Like you'll actually see that on this particular slide as I show you an example of range. But first, as I talked about measures of dispersion and why we what the different types of measures of dispersion are. Again, there's range, interquartile range, and then standard deviation. So we start off with range. And what range is, it's the difference between the lowest and highest values in a distribution. So again, high score and low score. If you have nominal variables, so where I'm at now is I'm explaining why we don't necessarily use range with variables measured at the nominal level. And here's why. If you have nominal variables, there's no ordering or distance function. Basically, nominal variables, they don't have a rank, so there's nothing there where you can actually place a numerical value on a nominal variable. You can't place a numerical value on being male or female. You can't place a numerical value on race. Different things like that. And those would be nominal variables. Remember, when we look at nominal, we use mode. Okay, we wouldn't use median for nominal. Okay, and we wouldn't use mean for nominal. Okay, so that's part of it. One of the things about quartiles and range, you at least need to be able to order and have means and variance. Okay, you need to be able to order things. And then when it comes to standard deviation and variance, they require numerical data, and so does range. If you don't have numerical data, you can't get the range. And nominal, when it comes to how that nominal level variables, when it comes to how we deal with those, we can't really get numerical data other than things like percentages. Okay, so again, we would not use range for nominal level variables, but range can be used with ordinal or integral ratio variables. It just depends on what's going on with the variable. That'll determine whether or not we use range. Now, one of the things, like I said, I want to go ahead and do a quick example. Range is one of the ones, to me, it seems pretty straightforward, but I do still want to go ahead and give you an example of the range. And so what I have here, one second, I need to redo my pen. Okay, so what I have here, I have an example that I'm going to write out for you. I'm going to give you a distribution of about 6 scores. So the scores are 1, 8, 10, 6, 7, and 13. Okay, pretty straightforward, right? And for the most part, most of you are looking at this and you automatically see what the high score and what the low score is. That's good. One of the things though that I like to do, even if it's a small set of numbers just like this, I like to put the numbers in order. And there are 2 ways you can do that. You can go from least to greatest. So that would be number 1 that would be, let me see, 1, 6, 7, 8, 10, and then 13. Okay, I kind of bunched my numbers up there, but you can see there's a, let me put commas in between them. 1, 6, 7, 8, 10, and then 13. The other option, so I'm gonna say option 2, is to put them from greatest to least. So 13, 10, let me see, 8, 7, 6, and 1. Some people prefer to do it this way because when you do the range, so I'm gonna come over here and I'm gonna write out the range. R stands for range, okay? So as you can see up here, that's what that R is, range, if you're writing out the calculation. So range is that high score, subtract the low score from the high score. And in this distribution, the high score is 13, subtract 1. That means equals 12. So our range is equal to 12, all right? So for this little distribution that I came up with, our range is 12. And again, let me just do this. There are 2 different ways you can write these numbers out. You can go from least to greatest or greatest to least. I know some people like to do it this way because they can see, I look at the first number and the last number, those are the numbers I subtract. Me personally, I always go from least to greatest. It's just the way my brain works. Okay, so that's range. Should be pretty straightforward, I would think. So here we go to another example. So this example, I'm not going to write anything out. It's already on the screen for you, but I do want to highlight a couple of things. So let's get the highlighter. So you'll notice here, they did it, if you remember my option 2, they here, and I believe this is also in the book, they do the option 2 way of doing things. They put the numbers in order from greatest to least, and that's fine. It's whatever is going to work for you. You just need to remember what those, that calculation and what those numbers are, okay? So they've taken the 46, excuse me, and then the 8, and here they are, 46, subtract 8 from 46, you get 38. And what that basically is telling us is the distance between the highest and lowest birth rates, because that's what this chart is looking at. The distance between the highest and lowest birth rates is 38, or the range of this particular distribution is 38. That's the range in numbers, all right? If you have any questions about any of this, you guys know the routine. Just send me an email and I will get to your question, or you can put your question in the Ask the Instructor discussion board, and I will answer your question that way as well. All right, so one of the things though about range is that range doesn't always, excuse me, range doesn't always give us all of the information that we want or that we need. And because it's based on only 2 scores, the highest and the lowest scores, it can sometimes be misleading. And this is particularly the case when there are extremely high or extremely low scores in a distribution. I'm going to demonstrate this for you right now. What ends up happening is, if say you have an extremely high or an extremely low score, it can lead to an exaggeration of the amount of dispersion in a distribution. So let's say that you have 2 different distributions. Okay, I keep losing my pen. Okay, so let's say you have two different distributions. Distribution 1 is equal to, or the numbers in distribution 1 are, actually, I don't want that. Okay, so let's try this again. It's just me being overly, um, not a perfectionist, but just I have a certain way that I like to write things. Okay, so distribution 1, not distribution I, distribution 1. Okay, so distribution 1 has the numbers 10, 15, 20, 25, and 30. Then distribution 2 has the numbers, some of the same numbers. It has 10, 15, 20, 25, and then the number 80. All right. So the range for distribution 1, so we'll just say range 1 is equal to 30 minus 10. That gives us 20. Then range 2 is equal to 80 minus 10. That gives us 70. So you see there's a big discrepancy there. But if you look at most of these numbers, most of the numbers are the same until we get to this one right here, until we get to this 80. This outlier is what we would typically call that, because it's such a large score within the distribution. And so the information that we get there for the range, it's exaggerated. And it's exaggerated, and it could be considered misleading. Now, this is a situation where you only have a high score. But what if you have two types of outliers? You have a really low score and a really high score. So let's look, we're going to look at distribution 3. So the numbers there are 5, 40, 50. Writing a little too fast. 50, 60 is the next number. And then 150. All right, so let's get that range for that. The range is going to be, range 3 is going to be equal to 150 minus 5. So now we have a range equal to 145. But that's not really accurate. And as you can see, this really low score and this really high score, based on how we get range, it again makes the information, it basically gives us misleading and exaggerated information. So when that happens, one of the ways that we deal with that is to look at interquartile range. Okay, this is one of those instances where it's better to use a different type of range. You know, when you have really large numbers, really high scores or really low scores in a distribution. All right, so interquartile range, that's what we're dealing with here. Got to get my pen back. Okay, so interquartile range, basically, it's a measure of range that divides the data set into quartiles, and that's what we have going on here. We have these different quartiles that section off the data set, okay? So again, interquartile range, Q, that's how we say interquartile range when we are doing the calculations. It's identified by Q. It's basically a measure of range that divides the data set into quartiles. Specifically, interquartile range looks at the middle 50% of cases within a data set. And the interquartile range is defined as the distance from the third to the first quartile. And the formula for it is, look at formula 4.2 on page 94 of the textbook. And it's basically Q is equal to Q3, quartile 3 minus quartile 1. The formula is also on the next slide, so don't worry, I will, you'll see it in a minute. But Q3, so here's Q3 minus Q1. So Q is equal to Q3 minus Q1. Whatever number is at that spot, so whatever number is here and whatever number we have there, that's what we would we would subtract Q1 from Q3 to get the that interquartile range, okay? Again, remember that the quartiles divide the distribution into quarters, okay? So it divides it into, I did it again. There we go. So it divides the data set it divides the distribution into quarters, so 25%. There are 3 quartiles in a distribution. Again, they're called the first quartile, which is Q1. So here's Q1. The second is Q2, and the third is Q3. Now, I know some of you are looking at this and you're saying, but there are 4 sections of 25%, 25%. I see 25% 4 times. That's what a quarter is, right? Well, for this, that's not necessarily how we're looking at that. The quartile is the point below whatever that quartile is. So for quartile 1, it's going to be the point below which 25% of the cases fall. So in other words, 25% of cases fall below, I want to highlight this for you, 25% of cases fall below, okay, so yeah, that's not the prettiest thing in the world, but 25% of cases fall below quartile 1, okay? So that would be quartile 1. Then for quartile 2, what we're looking at is the second quartile. This is the halfway point or the median of the distribution. This is essentially the point where 50% of cases fall below that number. So that I don't color over the yellow part, I'm just going to do this. All right. So all of that would be quartile 2. Okay. So because you've got 25%, 25%. So that's that 50%, excuse me. That's that 50%. Yeah, that looks crazy. That's that 50% that falls below. Okay. That's the 50% that falls below whatever this number is. In other words, so let's say this number was a 10. Well, we know that 50% of the cases or 50% of the scores are going to be below 10. That's what that is essentially telling us. Okay, I hope that makes sense. And then for the third quartile, this is the point at which 75% of the cases fall below. So let me write these numbers. So this is going to be 75%. This is 50%. And then this is 25%. So do you see how 25%? Then we have 50%. And then now we have the 75%. Okay. Again, don't look at the graph and think that this is referring to the 4 sections that you see. Again, the quartiles look at the point at which a certain percentage of cases fall below whatever that number is, okay? I hope that makes sense. Just know that Q1 is not going to start here. Q1 is going to start at the 25% mark. Q2 is at the 50% mark. Q3 is at the 75% mark. And if you go all the way to the high score, you're not going to have a quarter. You basically have the whole distribution. I hope that makes sense. If it doesn't, you guys know the routine. Just ask me questions and I will do my best to re-explain it or provide additional examples. All right, so what's gonna happen here is we are computing the interquartile range, all right? And I have it written out here, so I'm not going to go through and do all these calculations like I've done before. What I will do, however, I'm going to highlight a few things. All right, so What you want to do, again, is locate Q3 and Q1. However, you don't have to go through and count each one of these to try and locate Q1 and, excuse me, Q3 and Q1. Instead, there's a calculation for that. All right. Remember on the previous slide where I said that the calculation, where is it? Actually, oh, here it is right here. Remember I said on the previous slide, there was the calculation, and here it is right here. Q is equal to Q3 minus Q1, all right? But in order to get that, to get Q3 and to get Q1, we need to figure out what those numbers are. And rather than you go through and count each one of these, there's a way to do that. You would take 0.25, because remember Q1, what did we say Q1 was over here? Q1 is 25%, okay? Q3 is 75%. So all you need to do here is turn the 25% into a way you can calculate it. Well, remember, the way we calculate things in terms of percentages is we move the decimal place. So instead of 25%, we would do 0.25. And we know that there are 40 cases. So you take whatever number of cases you have, and here in this instance, there are 40 cases. So you multiply 0.25 by 40. That gives us the 10th case. Not the 10th case from up here, it's number 10 right here. Okay, and this is one of the reasons why I end up doing, when I rewrite these data sets out for stuff like this, I usually go from lowest to highest, and this is why. Because my brain automatically wants to look over here for the number 10, but I have to remember the rank is over here, and that rank is based on the score. So you see, and I forgot to show this to you on the last screen when I did the other example for range. Your lowest score is going to be your number 1 in the rank. Okay, not because it's the greatest, but because it's the lowest score. Your highest score is going to be whatever your highest number is. In this situation, we've got 40 cases. So the highest number is 40. So you take that highest number here, and that's what you put over here. So you multiply 0.25 times 40. That gives you it says 10th case, okay? You do the same thing with 0.75. 0.75 times 40 equals the 30th case. You might want to take a moment and try that on your calculator. I tested it out on the calculator on my phone, just a basic calculator, and I tested this out just to make sure. But we can see that 30, so that would be Kenya. Ooh, that's not the best. Okay, it'll work though. Case number 30, that is going to be the third quartile, if you will. Okay, this is going to be the third quartile. And so in order to get the interquartile range, I take this number, not the number 30, okay, not the number 30. I take this number, 35, and I take 13, because those are the rates for the 10th case. That's the rate for the 10th case. 35, that's the rate for the 30th case. I do not take the 10, I do not take the 30. That's just the case that corresponds to the score we want, okay? So then I take that score for Q3, the score for Q1, and I do the subtraction. I subtract 13 from 35, and I get 22. So I know that the interquartile range for this data set is 22, okay? All right, I hope that makes sense. Yeah, hopefully that makes sense. And let's see here, let me make sure. Okay. At this point, that is essentially it. Yeah, that is essentially it for interquartile range. Range and interquartile range are pretty straightforward. But if you have any questions, as always, you know the routine, just send me an email. And if I get enough questions, I will try to do additional examples for this. If I get enough people who need to see this done over again, okay? But here's the formula. This information is also in your book in chapter 4. So I will go ahead and get things started for part 3 of this lecture, and part 3 will start with standard deviation. You're definitely going to want to have pen, paper, and to try and follow along with the calculations for that.